So today we're looking at 11.2 and we're starting with number 25. So looking at 25 here, we are trying to use sine ratio or cosine ratio, whichever we fancy, as needed to find the measure of each indicated angle to the nearest degree. So a couple ways we can do this. The first way I would say though that most people would do is they'd probably solve for the C value. So as a first step, let's solve for C. If I've got this as a leg and this as a leg, then I'm basically just saying root 3 squared plus root 2 squared equals c squared. So here root 3 squared gives me 3 plus root 2 squared gives me 2 equals c squared. Add these up, take the square root, c equals the square root of 5. Only the positive one because we can't have a negative length. Uh-oh. Got some lag here on the picture. Oh boy. There we go. So looking at this, now we have root 5. I get a little pop-up saying my internet connection is unstable. It's probably all of the thorium reaction testing I've been doing. So looking at this one here, now I've got a setup for B and alpha, or excuse me, beta and alpha. I'm going to start with alpha here. So from alpha's vantage point, I'm going to put my little mol star map right here. This is my opposite. This is my adjacent, and now I'm good to go. So I can either set this up to solve using sine or cosine. It really doesn't matter. I don't know, I'll do sine for this one, and why not? So sine of alpha, I guess I'll show both ways. So I could say sine of alpha equals, so now here sine is SOHCA-TOA, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So as I look at this one, I'm going to set this up as root 3 over root 5. Now, if you want to simplify this thing, you can by rationalizing it. So you basically just multiply by root 5 over root 5. I'm not going to bother do that because my next step here is to find the actual alpha value. So I'm just going to do inverse sine of this. I'm going to make my calculator do it for me. So my next move here is to do sine -1 on both sides. So on the left, this is going to drop off and just leave me with alpha. So alpha equals inverse sine of root 3 over root 5, which gives us approximately, so let's check this out. Looks like about, we'll call it 51 degrees. So it comes out to be about 50.77. So again, just rounding to the nearest degree here. So we're going to call this thing 51 degrees. And we're good to go. By finding our alpha value, we have basically just found our beta value as well, because it's just going to be 90 minus the 51. So I'm basically just going to get 39 for my beta, and I am done. That's this setup. Now, if I wanted to use cosine, I could absolutely do that. I'll just show you the cosine setup, and then I'm going to pretty much just skip it for beta, because once you find one, you find the other. Well, I don't know. I don't know what the people want to see. Maybe the people want to see beta. So let's do beta and we'll do cosine. If I did cosine of beta, it would be, again, here's my adjacent here because it's going to be a switched vantage point. Here would be my opposite, and here we still got our hypotenuse. We're both always across from my 90. So this would be, oh my goodness, now here's root 3 over root 5. Spooky. It's the same ratio over here, but instead of doing sine, I'm doing cosine. Is it a coincidence that it's going to be the complement to 90? No coincidence there. So for our beta value here, we would do inverse cosine, and we get our beta value of approximately, oh, we already know the answer, but the exact answer would be 39.23. And we round that to 39. And we are good to go. Any questions on 25? Perfect. Let's look at 31 here. So with the airplane descending to land, the angle of depression is 5 degrees. So I feel like these pictures are sometimes a little bit confusing because it's always difficult to squeeze, well, not always, but it's often difficult to squeeze the angle in because the angle of depression will be really low. So here this 5 degrees is applying to this angle inside here. And the plane is reading 100 feet on its height here. And so now we're basically just trying to find the distance to touchdown. So this is the actual distance the plane will be traveling. So this orange line right here. So basically, I don't know the green thing. I'm going to call the green thing y, just to have another variable in place here. So basically now I've just got a setup. Keep in mind that when I've got the height over here, just like directly below the plane, that it's the same height over here. So I'm going to draw another straight line like this, and I'm going to put my right angle right here. So this is probably the triangle that most people would use. You can use this triangle and know that it's going to be equivalent anyways. I don't know what way you think about it. That's kind of the way I think about it, but whatever floats your boat. So let's look at this thing for 1 second here. Just realized those were my questions from 11.1. Answered yesterday. No questions today. No worries. I'll finish the explanation here in case anybody wants it. But no problem. So let's flip this thing. And let's flip it again. So this would be the triangle that I'd be using here. This is my 5 degrees. Up here, I don't know the distance. Here's the thing that I want. So again, this is my orange X value here. And then I've got my height, which is given to me as 100. So there's my right angle. So as I look at this thing, basically I'm going to set up either sine or cosine, right? If I tell you this is 5, we know that this is going to be 85. So if you want to do that, you can. But if I'm trying to find this side length here, and I'm going to start myself with a vantage point at this angle 5 here, this becomes my opposite. This becomes my hypotenuse. Here is my adjacent. So setting this one up here, I could use the fact that I have sine of 5 degrees equals 100 over x, and then I would just solve for there. So multiply by x on both sides, divide by sine 5 on both sides, so x is going to equal 100 divided by sine of 5, which we get approximately, call it 1147.37 there. So this is how we would kind of figure that out. And again, if I wanted to use this vantage point instead, and I want to use this 85, we can still figure this out. Here I just use cosine because I'm using my adjacent and hypotenuse. So either way, going to get the same answer for us here, about 1147. Any questions on this one? Perfect.